This is Rupinder. I'm from EduPristine. So today's topic is data dictionary and bivariate analysis. Now, could you please read this case study so that we can work on that? So in this case study, the question is Adam, an analytics consultant, works with First Auto Insurance Company. His manager gave him data having loss amount and policy related information and asked him to identify and quantify the factors responsible for losses in a multivariate fashion. Adam has no knowledge of running a multivariate regression. Now suppose he approaches you and requests for your help to complete the assignment. Let's help Adam in carrying out the multivariate regression. Okay, so to start with, we will be covering the first and the second part of this case study in today's webinar. The first part is basically creating the data dictionary, and second part will be bivariate analysis. Okay, so the data given to us is in this format, in which we have policy number, age of the driver, years of driving experience of the driver, number of vehicles owned by the driver, the gender, if the driver is married or not, or single, vehicle age, fuel type, and losses claimed basically. Okay, so let's look at the data. So the data we have is this with us. Now this is we now first, to create the data dictionary, we need to see what kind of variable it is. Okay, now in this screen, if you see, it says policy number. Now it's variable description, it's unique policy number, right? Age of the policy, that's already we discussed. Now what kind of values are stored in a particular variable and what is the variable type? Okay, to get to know about these things, we first need to get the unique numbers out of a variable. Now policy number, it's nothing but a unique ID, unique identifier. So we don't know, we don't want this, so we can just write unique identifier. Now before we go further, we need to know how many data points we have. So to calculate the rows, so we can just calculate count number of cells that are not empty. Okay, that will be these many. So we have the data points available to us is 15290, which is a big number, especially for Excel can handle data points up to like uh, much more than this number, but if we try to do this in any software like R or SAS, it will be much faster. But today's topic we will be covering in Excel. Okay, now how many variables we have? So we have count a 9. Now one can say that we can directly count, okay, there are 9, but many times we have much more number of variables, then it's easier to apply a formula than to count manually. So we have 9 variables and 15290 data points. Okay, now age, the second parameter is age. Now age is a number, right? It's a discrete number. Now we need to see how many discrete age numbers we have. So the one way is to copy it, paste it as values, then go to data, remove duplicates. Okay, continue with the current selection because we just need to copy just need to remove duplicates from this column. Okay, remove duplicates, age, yes. Okay, so there are only 55 unique values and others are duplicate values. Okay, so now I can rearrange this in an order, continue, sort. So now we have in increasing order 16 to 17, 16, 17, 18, 19. So directly we can say, okay, minimum age of the driver is 16 and maximum age is 70. Then similarly we can calculate the years of driving experience. We can just copy, paste, then remove duplicates, continue with the current selection. Okay, then again sort it, current selection, sort it. Okay, the number of vehicles, same way, remove duplicates, then now in this case we don't need to sort it, it's already sorted. Now gender can be male or female, but still in case, remove duplicates, male female, married, single, only two. Vehicle age, remove duplicates, then sort it. Is 0 to 15. So we have the brand new vehicle also, and we have vehicle as well as 15 years. Then fuel type, most probably it would be only two types, petrol and diesel. Let's see, remove duplicates, continue with the current selection. Yes, there are only two types, petrol and diesel. Losses, now losses is not a discrete number, it's a continuous number. We'll discuss in a minute. Let's remove duplicates. So there is only one duplicate value, everything else is unique. Okay, so you can see that it's not a discrete number, so it can take any number between a range. Okay, let's arrange an order. So we have loss as many as 13, close to 13, which is 12.5, and maximum is 3500, which is huge. Okay, now let's see. Now we have created the data dictionary. Now as a next step we need to go for loss analysis. Now for loss analysis we need to study about the distribution of the loss. Now as you can see, the data size is huge and Excel is going kind of crazy because of that. Okay, now let's see what's the minimum value of the data set. So as discussed earlier, it's around 13. Now we need to see the percentile. So if we want to study the distribution, we need to see how exactly it is distributed over the range from 0 to 100% in an ascending or descending order. Now percentile, if you might know that percentile is, if I say 90 percentile, 90 percentile means 90% of the data points are below my data point. That's 90 percentile. If I talk about fifth percentile means 5%. In this case 5% of the losses are below this number. That will be fifth percentile. Okay, let's make it 5 percentile. There is formula percentile, and we need to select, sorry, percentile. We need to select the select the array, then tell the which percentile. In our case, fifth percentile, 0.5, sorry. Okay, so 0.5 will be 50th percentile. So that is 67. So 5% of the losses are below $67. Then we can find the 10th percentile. Again the array, 0.1. So 10th percentile, right? Now that's 122. Okay. Now the same way we can calculate 97 percentile. 97 percentile will be 0.975. Then 981. So 97.5% of the losses are below 981. And then 99, which will be 0.99. So 99% of the data points are below 1200, so close to 1200, and 99 995. Now if you see our maximum, which we saw in the previous page, was 3500. Let's calculate again. Max of this data set. Max of this data set is 3500. Now 99.5% of the data points are below 1366, and the total 100% is at 3500. So you can see only 0.5% of the data points are between 1366 and 3500, which means we have some outliers. As you can see in the graph also, there are few outliers which I think maybe are not required in dataset, or we don't know. Okay, so to be on a safer side, and many times, as we know, is insurance company, when we apply for a claim, we don't get the full amount reimbursed. Okay, we get a limited amount. Okay, so it might be the case that we get only 1300 to the max. Even if we claim for 3500, we'll get only $1300. If we claim for 1100, we'll get 1100. Okay, but the cap is at 1300. So before we move further, we should do something about these outliers, because these can screw our results. Okay, before that, let's create a frequency table for this to further understand the frequency distribution. Now, interval range is how many number of intervals I want. Let's say 25. Okay, now let's say, as I told you, 99.5% is a very good percentage to study. Only 0.5% lies above that. So we'll study this only. Divide by, so interval size. So we need around 55 number of intervals with a width of 25. Now let's create. So 0. Let me delete this because it's creating a lot of problem. Okay, it's gone. Okay, now lower side is 0, upper side is 25. Now we can write it as concatenate this comma this comma this. Now 0 to 25. Okay, then we next will be 25 to 50. So I can write this as this and this as plus this. This is the fixed number because I need to keep a 25 as a cap. So I can drag these formulas till they reach the point. So it reaches 1300 and the final point should be 3500, which is our maximum value, right? So because there are only few numbers between 1300 and 3500, it doesn't matter how wide I am taking the last interval. Okay, so I need to drag this formula also. So it will be, I have pasted as a formula. Okay, now for frequency is an array function, so you need to select the whole array and then write the formula. It's frequency. Okay, then you need to select the data array is this comma, then you need to select which upper interval you want. So this is the upper interval. Now if you press enter, it will not work because it's an array function. You have to press shift control enter, then only you get this. So you got the frequency table. So the number of losses between 0 to 25 is 80. Between 25 and 50 is 420. Okay. So you can see that here it's lower on the left side, lower on the right side, and in the mid the number is higher, which is expected because average will be somewhere in between. Okay. Now we need to get rid of the outliers. For that we can cap it at, let's say, let's cap it at 1200. Okay, because as we saw 1204, 99% of the losses are below 1200. So we can study 99% and I think that will be good enough. Okay, so how to cap it? Let's cap it. Okay, now we need to see if it's below 1200 then it will be that number, and if it's above 1200 it will be 1200. So we can write it as equal to, if this is greater than 1200 then it will be 1200, otherwise this number only, right? So it was 203, so it will show 203. Let's copy paste the formula only. So I'm pressing Alt DS F. V means values, F means formulas. Okay, so I pasted the values. So if let's look at any number which is about 1200. So if you see here, there are few numbers which are above 1200, but we got it as 1200 after applying the formula. Now if you see, the graph is now more uniform than before. There are not much outliers. Okay, so this is our cap loss scatter plot. Okay, let's get rid of this. Now if we calculate the similar way the minimum and the maximum values, the minimum will be same because we didn't touch the lower side, we touched only the upper side. So minimum will be, losses minimum should be same as cap losses minimum, same. Even 97 percentile should be same for both. 97.5, so it's same, right? But if we check 99 and 99.5, that should be different. Let's see, percentile 99, 1204, percentile 0.99, 1200, because we capped it at 1200. The same way 99.5 also, 995, 0.995 again. So it's different. So it's capped at 1200. So we have played with the upper side. Okay. Let's see. Now let's copy the first three and paste it here. And frequency, for frequency it's a array formula, so it works in an array. So frequency for the old losses against the upper side. Okay, control shift enter. Now for this capped one, similar way, frequency upper range, control shift enter. So if you see, the number between 11,175 and 1200 has increased from 17 to 174 because above 1200 there is none, because we have capped it at 1200. Right. So that is the analysis of losses. So we have capped it. Now let's move to another part, which is bivariate analysis. Now to analyze, we need to individually study age, years of experience, number of vehicles, gender, merit, vehicle age, fuel losses. Now we have another number which is capped losses. Okay, I'll let you know why I've added count. Now before that, let's move to this. We now know what kind of values are stored. Values are stored as age as 16 to 70, years of driving experience 0 to 53, number of vehicles 1 to 4, gender female, male, married, single, vehicle age 0 to 15, like that. Okay, now variable type. Now first one is purely identifier. It's just to know which policy did what. Okay, age, it's a numerical and it's discrete, means that you can actually count, you can count the age. Okay, so usually the age provided in the policies or the credit card documents are is the age on last birthday, so it will be a discrete number. Now if definitely if you count till today, it will not be a number, it will be a fraction. So it can be, the age can be 17.5 or 17.6, but as we are talking about age on last birthday, it will be a discrete number, a whole number. Now years of driving experience, again the same way, it will be discrete. Number of vehicles, discrete, you can actually count. Gender, it's not numerical, it's male or female, it's binary, it's categorical. Married, in our case it's single or married, so it's again categorical and binary. Then we have vehicle age. Vehicle age is again numerical and discrete. Fuel type, categorical, binary. Losses, now losses are numerical but they are not discrete. Yes, you can see the number, but as we found out that there is only one unique value, so the loss can take any number between a range. So in our case, its range is huge, 0 to 3500, but can take any number. So it's just a measurement. Okay, so that's why it's a continuous variable type. Everything else numerical is discrete in our case, but this one is numerical continuous. Okay, now let's move to this sheet. Okay, the first parameter we have age, and we want to study about the age. Let's see. Now age. Now to study about the age, I will introduce you to pivot tables. Now pivot tables is when you go to insert in 2007, there's pivot table, press this and pivot table. Again, it creates a pivot table. It asks you the inputs. Now table range can be, go to data, our range is from policy number, we don't need to study because it's a unique identifier. We need to study from age to cap losses. So I'll select the whole range from age to cap losses. I selected it. Now where I want in the age sheet in A3. Okay, so I've created the pivot table, but what should be the input of these pivot table? What I want. So right now I'm studying age only, so I'll select the age. Okay, that's the first part. Now what I'm trying to study with the age, I'm trying to study the losses. Okay, now in our case it's loss, it's cap loss. Okay, now I told you that I have introduced count is nothing but it's calculating 1 to 1 1 1 1 in front of every ID. Now it is just to calculate the sum. Okay, so if I calculate count, now first of all, it is telling me sum of age. I don't need sum of age, I need the individual ages, so I will move sum of age to row labels. So if you see, now I have 16. So so in total 16 years age, the sum of loss for that particular age is 247712, and cap losses is 242289.83. sum of count. How many are there? 477. So that's why I need count. So 477 are there with the age of 16, those claimed for some loss. Now if you see, the sum of the count is 15290, which is equal to our data points. Okay, so it counts the total number. Okay, now what will be the average loss? Average loss will be this sum of losses divided by the number of people claiming. Now if you see, if I try to write the formula, it says get pivot data. It's long formula. Okay, it tries to get the value from the pivot table. Rather than that, if we try to calculate this average loss from the cell, so we can directly write it as equal to, the cell is B5 divided by D5, right? So I can close it. Sorry. So average loss for this age 16 is 519. Okay, 519. Then average cap loss. Average cap loss is this divided by this. Again the same formula. So I need to write C5 divided by D5. Okay, 508. It's slightly lower than the average loss because we have restricted our upper side. Now to see the percentage observations. Okay, percentage observation is try to see what percentage of people are of age 16 and are claiming for a loss. So it will be this. So it is D5 divided by, we need to see where is the sum, 15290, it's in D60, so it will be D60. Now we need to press F4 to fix this, because when we will drag the formula down, D5 will become D6, and if we don't fix D60, it will become D61, and we don't want to divide it with D61, we want to divide it with D60 only, so we will just press F4 again. So that's this. So around 3% of the people are lying in this range, this of age 16. So I've pasted the formula. So if you see this graph, as expected, the losses are higher for lower age and losses are higher for the higher age, and in the middle it's in between. Now why? So why I said as expected, because if you see, people who are of lower age usually have lower experience and there's high chance of accident, and people who are aged, they're old, right? So their driving capability goes down, so their loss also goes up. Okay, so in the middle, they are experienced, they are not that old, so their loss will be not that high. Okay, so that's age analysis. Now we will move to years of driving experience. Same thing we will repeat here. Again, the pivot table. So there will be shortcut, or there is also a shortcut, Alt N V and T will give you that range, and you can go to the previous sheet, and again select the same range, then tap, and yes, okay. So you can work on Excel without using keyboard also. Now I always recommend not using a mouse but work only on the keyboard, because you will save time, you will be faster. Moving the mouse takes time, but if you are practiced, initially definitely you will take much more time than by using mouse, but as you practice more, you will take much lesser time to work on keyboard. So press OK. Now I am trying to study years of driving experience. Years of driving experience against what? Against losses. Same thing. Count cap losses, right? But I don't want sum of years of experience. I want it as a label. Okay. Now the same thing I will repeat. So I will not write the formula. Okay, let me write the formula just to try to understand the years of driving experience. It should give me a result as expected. Okay, sorry. Now let me write the formula. It's B5 divided by C5. Now if you notice, the sum of count in the previous sheet was in D column, now it is in C column. Now if you want to shift this, if you move your cursor on any part of the pivot table, right side the field list will open. Okay, now what you can do is you can move the sum of count to down, and you'll see your sum of count has moved to the right. Okay, so it depends on you how you want it. Okay, now to change the formula I will do b5 then equal to c5 divided by d5 again. Okay, slightly lower as expected. Then percentage of observations, this, so again d5 divided by, now where it is, it's, I think it should be, okay, so we pasted it, so there is one less observation here, so it's d59, d59, so it should be fixed. So 9% of the drivers are having 0 years of driving experience. Okay, again, so here we are. the losses the losses are decreasing as we move towards the right. So basically as the years of driving experience goes down, moves down. Okay, now I said one thing different is age. So here we can see that the loss is going down as the age is going up. So in this, the age, so lower the age, usually lower the driving experience, so there is higher chance of accident, so the loss is higher. And as we move up to upper age, our loss goes down. Okay, now let's move to gender. Let's study about the gender. Okay, the same way I will alt n v t. Okay, create pivot table. Range, the range will be the same range I will select. Now what do you think, male will be having more loss or female? Think. Okay, so my guess usually is that female, it's widely assumed that female will be having more loss, usually has more lesser driving experience, or they don't know much driving, and so I think there will be a higher chance that female will be having higher loss. Let's see. Okay, now, okay, so let me select what, gender, losses, count, and cap losses. Okay, so it's again, it's selected well. I have female, the loss is 26. Okay, so the number of female drivers is more, but the sum of losses is lower. That's strange. Okay, now Okay, so that I understand, the number of female drivers is more, so there are more number of females as expected met an accident. But the severity of the accident was more in the male with the male drivers. Okay, that's a new learning for me. Okay, now it's again, so that's gender. Then we move to marital status. Okay, so married or single, what do you think? Who will be having higher loss? So I think married will be having lower loss because they, after getting married, they have family. They usually take care of the family and drive safely. Let's see if I'm wrong again or correct here. Okay, so I'll follow the same step. So I'll go to the data. I will. Okay, so it will ask me to place. Okay, so I need merit losses, count cap losses. Okay, so the number of people who are married are more, and the loss is lower as expected. The loss is lower. Okay. Now, again, this severity is lower in marriage, so they drive carefully. They may drive, I mean, slow than the drivers who are single. Okay, so this was as expected. Now, vehicle age. What do you think? Vehicle age. Let's see. Again, the same process. So I'll go to data. Then I'll go to vehicle age, losses, count, car losses. I don't need summer vehicle, I need like this. Okay, then okay. So I got the losses again. Summer count is coming in between. Let me move to the down. Now it's on the right side. Okay. Now average loss. Average loss is C5 divided by E5. D5 divided by E5. Observations. E5 divided by E21, which will be fixed. Okay, that's quite uniform, or not uniform, sorry. So the fewer number of the lower the age of the vehicle, lower the law. Sorry, higher the loss, and higher the vehicle age, lower the loss. Okay, so there we find a trend. Usually, I was thinking that what to do with the vehicle age. It should not matter. It should matter on the driving experience rather than vehicle age. Okay, that's a good learning for me again. Then number of vehicles. I think it should not affect because again the number of vehicles. If I own 5 vehicles or 10 vehicles, it should not matter how many vehicles I own. If it should matter that how experienced I am. Okay, let's see again. Alt N VT. Okay, let me select the data. Again, the same data. Okay, press OK. Yes, I want to replace. Then what I need to select? I need to select vehicle, number of vehicles. Where is this? Losses, count, cab losses. Okay, so I don't need sum. I need count on the right. We have this number. Okay, let's try to calculate average loss. Average loss will be C5 divided by E5. Sorry, I wrote R5. So R5 is actually zero number. So E5. D5 divided by E5. And the percentage of observations E5 divided by E9, which should be fixed. So we have this. So the number of vehicles is like this. So if I have one vehicle, I have higher loss, and as I go down, it's like almost flat. If you see the red line is almost flat, so it should not. So cap loss should is not does not matter with the vehicleage, but if it's not capped, then there is a trend. It's a kind of smile. So higher number of vehicles, higher loss; lower number of vehicles, higher loss. In the middle, lower loss. Okay, but as we are studying the capped losses, I think it should not depend, the loss should not depend on the number of vehicles. This we will see when we'll go for the regression, full regression in future webinars. Okay, then let's study about the fuel type. Okay, the fuel type, same way we will go for fuel type. Okay, alt and VT. Let me go to the data, H. Okay, okay. I will select fuel type. Again, here I am thinking that it should not depend on fuel type because it's a fuel type. How, if it's a diesel or petrol, how it depends on the loss claim? I don't understand that. So there might be a reason. Let's see. So it's diesel and petrol. Okay, and average loss will be C5 divided by E5, and cap loss will be D5 divided by E5, and the observations will be this. So E5 divided by E7, which is fixed. So though it was clear from the above, again, so we see there are higher number of people driving the petrol car. Okay, but the average loss is lower for the. So if I drive a diesel car, the I have lower number of people driving diesel car, but the amount of loss claimed average is much higher for people who are driving petrol car. That's strange. It might be because diesel cars are usually heavier cars, and they, whenever there's an accident, it may cause huge loss here. That's all I can think of in the diesel car. Okay, so there is a relationship between diesel car and petrol car with the amount of loss claimed. Okay, so this was today's webinar about the data dictionary and the bivariate analysis. Hope you it was beneficial for you. We also have a full-fledged course which we launched in US in 4 cities. The details of which my team members will send to you in email. So guys, please give feedback. It will motivate us. Okay guys, thank you. Thanks for your time. Take care. Bye.